Okay. In this first example, you can see that we've got really ordered particles here and really disordered particles here. So that means when you're moving in this direction, this would be a positive delta S. Okay. And then for the exothermic direction, this direction here is your negative delta H. So you can see that they're pointing in the same direction to the left. When this happens, there is virtually no reaction that will take place. Okay. The two equilibrium positions that we talked about are happening here in this corner and down here. Okay, so here I've got my increase in entropy. Here I have my negative delta H. They're in opposing directions, so we'll hit equilibrium with reasonable amount of reactants and products. Over here, going to the left, this is my positive delta S. Going to the right is my negative delta H. They oppose each other, so we'll form an equilibrium with a reasonable amount of reactants and products. And then over here in the bottom right, you're going to see that as you move in this direction, we're going from ordered to disordered. So this would be a positive delta S. And then as you move in this direction, this is my negative delta H. Since both of them are pointing towards the right, we go virtually to completion. You will sometimes have them say that this does not occur for this upper left-hand box. Okay, so let's go ahead and take a look at a couple practice problems, and then we're pretty much done. Okay. I need to come back to this spontaneous thing when we're done with the practice problems. So let's take a look here. Okay, number one, they want to know if this reaction will achieve equilibrium, go nearly to completion, or almost not occur. So here I've got a positive delta H value in the forward direction. So that means this direction will be my negative delta H. You need to take a look at the states of matter and determine how many particles we have. I have 3 on the left, 2 on the right. So doesn't that mean left would be a positive delta S? What does that tell us?
Doesn't happen.
Yeah, so this will almost not occur. For the next one, it says, this reaction establishes equilibrium with a reasonable amount of reactants and products present. They want to know if it's endo or exo. So maybe we should just take a look at the states of matter first and determine which direction entropy is increasing in. So here we've got 2 reactants and 2 products. Okay, so did I count that right? Yeah? Okay, so is there something else that we could look at? Maybe?
Another value was separated.
Okay, so what looks oxygen is the one? Oxygen kind of became more organized, didn't it? So oxygen went from being in 2 different gases to being concentrated in 1. So do you think this is an increase or decrease in entropy? Okay, so that means this direction is my positive entropy. Yes? Okay. So that means, wouldn't this direction have to be my negative delta H if I have a reasonable amount of reactants and products present? Okay, so then that means that this reaction would be exothermic, right? Because that direction is negative delta H. So that means heat is released. Okay. And then the last one. this reaction has a reasonable amount of reactants and products present. They want to know what the entropy is doing, increasing or decreasing. Well, they gave us a negative delta H. So this is an exothermic reaction in this direction. Okay, so I'm going to highlight the states of matter. I'm going to count the number of particles I have. Don't I have 2 on each side? Yeah. Okay. And then if I have a reasonable amount of reactants and products present, what does that mean about my entropy? Wouldn't my entropy have to be increasing in this direction? So that means for the forward reaction, entropy decreases. Okay. Okay, last thing, spontaneity. When you have a process that happens on its own without intervention, it's called a spontaneous process. Generally speaking, chemical systems move spontaneously towards equilibrium. Okay. Are there any other pages after this, or is that it? There's a little blurb on that one page. Let's see if it's anything. This just talks about how spontaneous processes can occur extremely slowly or extremely quickly. Like, do you remember when we put that nail in the solution and it rusted? That was a slow single replacement reaction. Also, diamonds forming, very slow, spontaneous reaction. That's pretty much all that this is talking about. So this